In this problem, we need to prove that a squared plus b squared equals to x squared plus y squared whenever x and y are given by the following trig equation. So let's begin. So here we have x given by a times cosine theta plus b times sine theta. And we have y given by a times sine theta minus b times cosine theta. So we'll start by first squaring both sides of x. So we have x equals to a times cosine theta plus b times sine theta whole square, which will be equals to, so we have a squared times cosine squared theta plus b squared times sine squared theta plus 2 times ab times cosine theta times sine theta. So let's label this as equation number 1. So this is the value of x squared. Similarly, we're going to square both sides of y. So where y squared equals to, we have a squared sine squared theta plus b squared cosine squared theta minus 2 times ab sine theta times cosine theta. So let this be equation number 2. Now we're going to add equation number 1 with equation number 2. So that's going to give us x squared plus y squared will be equals to, so we have a squared cosine squared theta plus b squared sine squared theta plus 2ab times cosine theta times sine theta. So this is the value of x squared. This will get added to the expression on the right hand side of equation number 2, which is a squared times sine squared theta plus b squared times cosine squared theta minus 2 times ab times sine theta times cosine theta. So here we can quickly cancel out 2ab cosine theta sine theta, and now we're going to combine a squared cosine squared theta with a squared sine squared theta by taking a squared as the common factor. We have a squared times cosine squared theta plus sine squared theta. Then we will combine the remaining term b squared sine squared theta plus b squared cosine squared theta by taking b squared as the common factor. So that will get multiplied to sine squared theta plus cosine squared theta. Now luckily cosine squared theta plus sine squared theta, that's a standard trig identity with a value of 1. So we are finally left with a squared plus b squared. Hence we have successfully shown that our value x squared plus y squared, so that's equals to a squared plus b squared. So this is what we are asked to show, hence proved.